throughout the West, and every single night it was just like stars in the sky. It was so nice.
Yeah.
Just like the diamond caves.
You know, it's not so bad even if you go out to Montauk. There's not that much light pollution out on the East End. But where we live, we're so densely populated. If you go on Google Earth, you'll see the houses everywhere. So the whole East Coast of the United States, okay, is lit up. What is density? Density is the concentration of matter. So if you have a certain amount of matter, if you spread it out, it becomes less dense. If you compress it, you usually go from a gas to a liquid to a solid, and it becomes more dense. If you want to visualize it, you can look at these pictures right here. This picture on the left, they're a little bit more spread out than on the right. So B would be the solid and A would be the liquid. Okay? If you were to heat that up, the A would turn into a gas. The way it works is molecules, when you heat them, they move faster and faster, okay? And they crash into each other, they spread out, and they exert force on their container if they're, in a sealed container. And that outward pressure, allows it to expand. So think how close are molecules that are spaced. The solid on the right, liquid in the middle, and a gas would be over here if you continued to heat it. Calculating density. Everybody in here good at math?
Yeah.
Yeah? Okay. All right, so if you have any questions, you got to call Grace, okay? She's said she's good at math.
Yeah, I'm good at math.
So anyway, if you're not good at math, what you can do is you can refer to your reference table. This is the reference table. Okay. This is your reference table right here. It's a 14-page booklet that has all these charts and diagrams and things. All you have to do is know how to read it. You don't have to memorize any of this. And the nice part is all the formulas that you need are located right over here. And today we're going to talk about density. Okay? Density is the mass divided by volume. Those are the two variables. Mass is in grams. And volume is the amount of space it takes up. We live in a three-dimensional world, so we need a length, a width, and a height. This is in cubic centimeters. If we measure using a graduated cylinder, it's going to be in milliliters. Lucky for you guys, 1 milliliter is equal to 1 cubic centimeter. So whether we measure the length times width times height, or if we measure the volume using a graduated cylinder or something to that effect, they're going to be the same. Any questions? Did you guys do that in the younger grades? Work with density? Maybe?
Yeah, in 6th grade we did.
Okay, good. So anyway, to make a long story short, here's the formula, and you don't have to memorize it. Now, let me get my cursor back. This is the formula. Sometimes you'll be given an object, and you'll have to figure out what the density is by weighing it. Okay, you got to get the mass, and the other variable is the volume. So first of all, if you have a triple beam balance, you put the weight on the balance. Like, let's take this one, 457 grams. To refresh your memory, if you didn't use this, okay? Blake, what are you, a bat? Okay, so 457, the way it works is this is zeroed. Remember we talked about zeroing a balance for precision and accuracy? You slide the weight to the right, and if it's 457, it's going to tip when you go higher than 457. So you'll get up to 500, and then you have to back up one. so the slide would end up right here. Then you go to the tens, slide this over. 57 is less than 60, so you would hit 60, this would drop down, then you back it up one, and you would be here. And then last but not least, you usually take the single grams, slide it over. Sometimes people tap it with their pencil, and you would end up right here. So when you read a triple beam balance, there's 1, 2, 3 beams. It's 4, 50, 7, and the units is grams. Okay? We'll practice using those in class, but I just wanted to refresh your memory how to read it. So we go up here and here. Okay. Volume is length times width times height. When you have a cube or a rectangle, here's a cube, here's a rectangle, the length is usually the longest horizontal distance, the width is the shorter horizontal distance, and the height is from the ground up. So this is length times width times height. You multiply those three numbers, and it gives you the volume. Okay, we'll be working in centimeters. That's what this is. These are centimeters, and there are 10 millimeters in a centimeter. So this right here, if you measured from 0 over to, say, this point on the ruler, it would be 3.5. At the end of the year, if you take the Regents exam, they ask you to, in the practical, do some measurements to the tenths place. So we try to stay consistent throughout the year, so it's fairly robotic when you take the Regents. Okay, moving on up. Okay, now if you don't have a cube or a rectangle, you have to do water displacement. And water displacement, basically what you do is you put an object in. Okay, oh, that's a little big. You put an object in, like this kid, into the barrel, and however much space this irregular shaped object takes up, the water level will rise. So we go over here. Most things don't fit in a graduated cylinder, so we use something called a dribble cup. And with the dribble cup, you fill it with water up to there, and the water starts to dribble out. And once it stops dripping out, it's perfectly level with this spout. Then what you do is you take an object, throw it in there, the water level goes up, the water comes out, and you catch it in the graduated cylinder. Okay? Now, a graduated cylinder, when you read it, looks like this. Okay? This is my best graduated cylinder. Graduated means that it's got numbers on it. So when you fill it up, you fill it to a nice rounded number. For instance, like 20 milliliters. And you always read from the bottom of what we call the meniscus. Water climbs up the sides because of something called adhesion, which is water to a surface. Like if you have water on your hand and you flick it at the window, the droplets will stick to the window. They won't just run down. That's adhesion. And cohesion is water to water. If you had two little drops of water and they touched, they would suck together. Water sticks to water. So if you fill a graduated cylinder with water, you get a meniscus. If you take a straw, stick it in water, you get a meniscus. Same thing. Okay. Then what you would do is you would throw the object into the graduated cylinder. The water level will go up, and however much the water level goes up, like let's say it went up to 25, then your your object would have a volume of 5 milliliters, or the other unit that's interchangeable is 5 cubic centimeters. Okay? So now I slide down here. These are some practice math problems. We're going to be doing those in class. Over here, find the density of this figure. You would find the well, they give you the mass, and then the volume is the length times the width times the height. You multiply those three numbers. Okay? So sometimes you'll use a triple beam balance. Sometimes they'll give it to you. Sometimes they'll give you the volume. Sometimes you have to do length times width times height, or use a graduated cylinder. Now, what this is a mass volume graph. This graph has the ability to show densities. For instance, this line right here represents the density of a sample. It could be sample A, whatever that may be. If you remember the way you calculate density, it's D equals M over V, okay? So what we would need to figure out the density of this line is a mass and a volume. Which volume do we use if we have a mass of 250? You go up till you hit the line, and then you go across, just like that. So that would give us a mass of 250 would give us, okay, this should have been a little bit higher, a volume of 250. What's 250 divided by 250?
1.
1. Okay, so the density of this substance at this point is 1. Now, I wasn't paying attention to the mass I picked, which actually worked out good, because I want you to realize when you're calculating the density of this line, this material, it's easiest to always pick a point that's intersecting, like for instance right here, so that you get nice rounded numbers. I picked 250, I went up and I landed in the middle of a line, and I had to estimate over here. I knew the density of this line was 1, so it didn't matter, but you'd be better off look at the line and try to find where it intersects right on a corner. So this one's 300, go up till you hit the line, go across, 300. So 300 divided by 300 is 1. What you just discovered was that the density of this material all throughout, no matter how big it is consistent, doesn't change. Okay, so we have the same density all along that line. Now what this graph does is, if we have another material with a slope, let's say material B, and we want to know, does that substance float or sink if it was put in liquid A? What you could do is calculate the density of this one. This is 150 and 300. So it would be 150 over 300. Let me grab a calculator and show you.
2.
Yeah, no, I know what it is, but I'm just showing you. So it would be 150 divided by 300 equals 0.5. So you plug those numbers into your calculator. You go over here. This one's 0.5, and this one's 1. The less dense something is, this is the lower density, less dense things float. So if you placed object B into solution A, B would float. What do you suppose would happen if there was object C down here with a less gradual slope? What do you think that would do? Blake, help me out. Is C going to sink or float? What's going to do?
Float.
Oh,
Actually, no, it's heavier, so it's going to sink.
right, it's going to sink. Like if we calculated the density, it would be 450 over 200. That's going to be more than 1. Okay, so this substance right here, does anybody know just by chance what the density, what substance has a density of 1?
Water.
Yeah, very often on these charts, actually almost all the time on the Regents exam, they have water as a reference, and then they base their questions off of that. Okay, so that's the volume mass chart. Also, important ideas about density. We talk about flotation. When mixed, more dense objects will sink, less dense objects will float. The density of liquid water is 1. If you forget that, once again, we got the reference table. And density of water at 3.98 degrees, sometimes they round that to 4, is 1. So 1 gram per milliliter. What's the other unit that we could substitute for milliliters?
Centimeters cubed.
Perfect. Okay, cubic centimeters. We'll do this. Well, the reason I keep bringing up the same things over and over again is through repetition. That's how you commit things to memory. So you got to hear it many times before it becomes, ingrained in your long-term memory. All right. So what I'll do is I want to show you one little 2-minute video, and we'll talk a little bit more, and then we're done because time flies. Okay. This video has to do with flotation and density and soda, and I find this interesting because how many of you drink soda? How many drink a lot of soda? Okay, we'll see how many people want to drink soda after this.
All right, so fourth graders around the state do this whole unit on nutrition. It seems to be third, fourth grade they hit this nutrition thing, and so I love to pull this out for that one because sometimes you don't really even know what you're drinking,
Perhaps, and there's few kids that don't love soda. They will try and beg and negotiate.
Everything, and yeah, absolutely. So this is kind of fun, just a tank of water, all right? And notice all of our cans of soda, it's just a nice variety of Coke and Diet Coke and Pepsi and Big K and whatever. None of them have been opened. All right, so they're all kind of the same. All right.
Okay.
So question for you: if I take the can of soda unopened, float or sink?
Sink.
Why?
Yeah.
See, I
I don't know because there's still stuff in it.
Okay, there's stuff in it. Good.
Right, there's still.
Okay, good. Right, nice.
Right.
How about Big K? Float or sink?
I'm gonna say sink.
Yeah, very good.
Okay.
Now, did you have parents that used to throw the can into the swimming pool and then you had to dive down and get
Oh,
it?
that's
And it kept
part
us
of the
busy?
big
Yes.
swimming. Yeah.
Thing for 4th
Are
of
you
July.
kidding? That's
All
so
right,
fun.
So
for
now,
4th of July.
Diet Coke is exactly the same, 355 milliliters, 355 milliliters for a sink.
Sink.
Absolutely, so that one will sink as well. And then if we try the Diet Pepsi, wow, there must be
Wait a
an
minute.
air bubble. That's what it is. There's an air bubble. And it's, oh my gosh. Wait just a second. Kim, out of all these here, which one's going to float, which one's going to sink? There's a Diet Pepsi, there's a sparkling water, and a grape. Which one's going to float?
Well, then I'm going with the diet.
Let's go for it.
Let's
Drop it right
try
in there
it.
and see if you're there.
It is.
That's just, is
Okay.
it? How amazing is that? Isn't that kind of fun? Now, there's not air bubbles underneath there. It really is floating. And so the general rule here is that everything that's diet will float, everything that's regular will sink.
Sink.
So try that sparkling
That's
water
what I
just to
wanna
see
know.
if that's,
Let's
there
see
you
what
go, float or
happens with
sink,
the-
and we get a little floating action that's there. So what's the difference? And I asked a group of 4th graders, what's the difference? The little girl, in all honesty, says it's the calories. This has 150 calories, and this has no calories at all. And the calories don't really weigh anything except for the holidays, and they do. What's the
Yes.
big difference between the two? If you look at
Gotta
the
be the
difference,
sugar.
got it, right?
Sugar.
So how much sugar in here?
Oh, I don't know.
A lot of sugar. 39 grams of sugar. But
Okay, so
you know why they
is
put
that
it in
teaspoon?
grams?
Why?
Because we're Americans and we don't get that.
Yeah,
so
because it means
39
nothing to
grams
me.
must be nothing, right?
Right.
So how much is 39 grams? Well, I think maybe the best equivalent is for here. Hold out your hands right here. I'm going to put packets of sugar in your hands. You tell me when to stop, all right? So here we go. 1, 2, 3, 4. More than that?
I'm thinking more.
Okay, 5, 6, 7. You tell me when to stop. 8,
Oh,
9.
that's enough.
Okay, keep going. 10. Keep going. 11, 12. You want to stop?
Yeah.
No, 13, 14, 15, 16, 17, 18. Roughly 18 packets of sugar in that Coke that you see down there. Now, we've taken some liberties because there's high fructose syrup and so on, but about 18 packets of sugar. That's only 39 grams. Take a look at this guy over here. This is grape soda, so this is going to be
Right.
really good for you. How many grams right there?
Oh, 14?
No,
No,
50
60.
50
I can't see.
It's okay. Sorry.
I'm sorry.
54. 54. Watch this thing sink like a lead balloon.
So
That just
sick.
bam. Isn't that amazing? So if you go to the restaurant and get one of them bladder busted big ones, that's about 5 times that. That's about 100 packets of sugar. So the density, the reason they sink is because it's more dense, and so when you have on the scale, you can see the difference.
All right, so if you drink a 12-ounce soda, you eat 18 packets of sugar. If you go to 7-Eleven and you get a big gulp, it could be 100.
I still want it.
Yeah, I'm still gonna drink some soda.
All right, I tried.
Actually, let me get a glass right now.
All right. So anyway, friends, it's 11:57. You're a couple minutes over. All right, Blake, go for it. How big is that? Oh, well, that's only like 9 packets. That's half.
Yeah, that's not that big.
Okay, that's all right. All right. So if you have any assignments that you're missing, do them tonight. Catch up. Okay, I'm not going to give you a Cami assignment or anything tonight, and we'll pick up where we left off tomorrow.